Hi, Algebra 1 students. Mrs. Paglione here. Last week, we talked about factoring binomials, so two-term polynomials using the difference of squares, of two squares method. And we also talked about the grouping method, which allowed us to factor four-term polynomials. Today, we are going to start our lessons. It's going to take a couple of weeks, but we're going to start talking about trinomials, so three-term polynomials. These are the easy trinomials, okay? Definitely the easy trinomials. And then in 2 weeks, we'll dive into more challenging trinomials where we will actually use something called the British method. All right, real quick review though, possible factors of numbers. So factors are numbers that multiply to equal the bigger number. So two numbers that multiply to equal 12 would be 1 and 12. I like to list them out like this. I don't know why, I guess maybe because my teachers when I was your age did it, but 2 and 6 and 3 and 4. So those are my factors. Also, a list of factors is -1 times -12 will also give you a positive 12. And -2 times -6 will also give you a positive, and -3 and -4. Okay, so that's something to consider here. We're not just talking about positive factors, but two negative factors will also give you a positive result when you multiply them together. And then the same thing with 18. If I want -18, that's -1 and 18. But I could flip it around and make it +1 and -18. Okay, so when you have a negative number that you're trying to multiply to, the negatives can flip to one or the other, the smaller or the larger factor. So that would also be -2 and 9, or +2 and -9. And then -3 and 6, or +3 and -6. Okay, so kind of just keep that in mind. That's going to matter because we're going to be talking about factors, so things that multiply to equal a number, but then we're also going to be talking about sums, so adding things. So if you're adding two positives, it's different than adding two negatives together because your result would be negative. All right, so the general form of a quadratic trinomial, so that's ax squared plus bx plus c. Okay, that's the general form, the standard form, if you will. Now let's go backwards. Let's see if we can find a pattern. So pause the video right now, and I want you to use FOIL, or maybe you want to use double distributing. Go through and figure out what the first two binomials and the second two binomials would be after we FOIL them out. So after we write them in expanded form, and see if you can see a pattern. See if you can see how we were able to get 5 and how we were able to get 3. And same thing with -2 and +3. So go ahead and take a second and do that for me, please. Okay, when I FOILed or double distributed the first one out, I got x squared plus 8x plus 15, and the second one I got x squared plus x, or 1x. I just wrote the 1 there so we could see it -6. Now I'm hoping what you were able to see, and the pattern you were able to see, is 5 and 3. If you add them together, you get 8. If you multiply them together, you get 15. Same thing here, -2 and 3. If you add them together, you will get a +1. If you multiply them together, you'll get a -6. So if we wanted to go backwards, we have to figure out what numbers multiply to the end numbers. So what are the factors of the end numbers? What's the factors of 15 and the factors of -6 that multiply, obviously, to those numbers, but then they have to add to the middle number. So that's why if you go back to the warm-up or the beginning review, I listed out all those factors because that's multiplying, but then we're actually going to go through the step of adding them together and trying to figure out what that number is. And we're going to try and get that number to be the middle number in our trinomial. So the steps are, you want to think what factors of C, so that's the end number, that add up to B, which is the middle number. Okay, that's what you're thinking. And then what you end up doing is you end up writing your answer as x plus or minus, depending on what it is, the first factor, x plus or minus that second factor that you find. How could you check to see if your factors are correct? You can go through and FOIL your answer and check, or double distribute. Okay, so another way you're going to hear me talk about this is the add multiply method. And just like A comes before M in the alphabet, add is going to come before multiply. 5 5 is going to come, that goes with the add, multiply, 4 are going to go together. So I sometimes call this the add multiply method. So factor this trinomial. So I need numbers that multiply to 4. So I'm going to go through and write all the factors that could multiply to 4. So that's 1 and 4. That's -1 and -4. That is 2 and 2, -2 and -2. And I need to pick the pair that adds to +5. I have to pick the pair. Well, that actually ends up being my first pair. My first pair of numbers add to +5. So that's the pair I'm choosing. So my factors are +1 and +4. So when I write my answer is going to be x plus 1, because +1 is one of my factors, times x plus 4. And I can always check that by multiplying or FOILing or double distributing, however you want to think about it. You can also write your answers the other way. So the order does not matter. Okay, so if an answer key is written like x plus 4 times x plus 1, it's going to be the same thing. And when you're completing your IXL, it doesn't matter the order for IXL either. All right, looking at the next one. So we're going to factor these trinomials. So I like to call it the add multiply method. So I need two numbers that multiply to -21, which means one of them has to be positive and one of them has to be negative. Okay, so that would be -1 and +21, or +1 and -21, or -3 and +7, or +3 and -7. Now I'm looking for the pair that that adds to -4. So the bottom pair is the pair that adds to -4. 3 plus a -7 adds to -4. So those are going to be my two factors. So my first set of parentheses is going to be x plus 3. My second set of parentheses is going to be x minus 7, or plus a -7, doesn't matter. As the numbers get bigger, it might be harder to find the factors, so listing out might be easiest for you. As you get through more and more problems, especially as you get through your homework, you will probably pick it up without having to list out, and that's perfectly fine. You don't have to list out your factors if you don't need to. All right, -35. So it's add multiply. I need two numbers that multiply to -35 but add to 2. So that's going to be -1 and 35, or 1 and -35. And then what's that? 7 and 5. So -5 and 7, or +5 and -7. I've already found my pair. My pair are right here. -5 and 7 added together is going to give me the middle number of 2. So my answer is x minus 5, x plus 7. And once again, it doesn't matter the order, and you don't need to list out your factors if you can see what the answer is. All right, looking at the next one. Once again, add multiply. So multiply to 18. So that's 1 and 18, or -1 and -18. That's also 2 and 9, so +2 and 9, or -2 and -9. It's just kind of the similar numbers that we have up at the top. We have +3 and 6, which gets us very close, but they have to both be negative, because that's how we're going to end up getting the -9. So if I add those together, I do end up getting -9. So my factors are going to be -3 and -6. And like it says up at the top in that box, you can always FOIL to check your answer. That's the nice part about this. You can always work backwards and multiply, kind of like our previous unit, to check our answers. All right, looking at this one. So we need two numbers that add to 2 but multiply to 1. Well, multiplying to 1 is either going to be +1 and 1, or -1 and -1. Well, +1 and 1 are the two that are going to add to 2. So your answer is x plus 1, x plus 1. But there's actually a better way to write your answer. So since I have the same factor written twice, or the same sets of parentheses written twice, you want to write it with an exponent. Since we're not really going to have a major assessment, if you write it as x plus 1 times x plus 1, I don't believe that IXL is going to count you wrong. I think they're still going to have that as an okay answer. Next year, when you're in geometry or algebra 2 the following year, you're going to want to write it with an exponent. If you write it broken up on your homework, not that big of a deal, just the answer key is going to have it written with an exponent. All right, next one, add, multiply. So I need two numbers that add to -1 and multiply to -30. So -30 is -3 and 30 and 1, or 30 and -1. Like I said, you don't have to list out the factors if you don't want to. 2 and -15, or -2 and 15, -3 and 10, 3 and -10. Haven't gotten to -1 yet because it's 5 and 6, some form of 5 and 6. So -5, +6, or +5, -6. So since I want to get to a -1, that bottom pair is the pair that's going to get me to a -1. So that's going to give me the factors of x plus 5 and x minus 6. All right, last one before we talk about factoring completely. So we want to add to -8, but multiply to -20. So -20 is going to give me -1 and 20, or +1 and -20. Neither of those are going to give me -8. What about 2 and -10? Nope. What? Oh, 2 and -10. Yeah, that's it. 2 and -10. Okay, that right there, that's going to add to -8. So my factors are going to be a +2 in my parentheses and a -10 in my parentheses. If you want to write plus a -10, that's fine as well. Okay, the next couple is called factoring completely. So the reason why the directions would say factoring completely is there must be a GCF you can take out at first. So, and you can notice that you're going to have a leading coefficient for all of these, which means that you're going to have to pull out a number because none of our examples that we've been doing have had a leading coefficient. There isn't a number that's attached to the x squared. So it probably means I have to factor out a GCF to get an x squared by itself. So that's kind of a little bit of a hint for now. So if I'm factoring completely here, I'm going to look at all of these numbers and I know that I can divide them all by 4. So I am going to divide them all by 4, which on the outside leaves me with a 4, then x squared minus 3x minus 70. Make sure we do the add to -3 and multiply to -70. So -70, I'm not going to list out all the factors. I will know it's 7 and 10. So it's either a -7 and a +10, or a +7 and a -10. And it's going to be the second option because I need to get a -3. So if I add those together, I do in fact get a -3. So the 4 is on the outside. And then my binomials are x plus 7 and x minus 10, in whatever order you want. Just make sure to keep that GCF on the outside. So a lot of times kids highlight it so that they can remember to keep that GCF on the outside. All right, next one, we can divide them all by 5. So if I go through the process of dividing all of these by 5, I'm going to get a 5 on the outside, x squared minus 14. X, and then 245 divided by 5 is going to give me 49, so plus 49. So I need two numbers going back to the add multiply, so add to -14, multiply to 49. So two numbers that multiply to 49 are 7 and 7, or -7 and -7. So since I have to add to a -14, it's going to be the -7 and -7. So I have to keep that 5 on the outside, and then it's x minus 7, x minus 7. But like I said before, you should write that with an exponent. Okay, so if we were in class, I would definitely make you write that with an exponent. But you know, since we're not together and times are weird, if you wrote it separate, that'd be fine too. All right, I'm going to do the last one, and then we're going to have to do a second video for the last few at the bottom. All right, my GCF here is a 3, so I'm going to divide them all by 3. So a 3 is on the outside, and that gives me minus 121. Since it's a binomial, it's a difference of 2 squares, and that would be 11 squared. So this 3 stays on the outside, and it's x plus 11, x minus 11, or the opposite order. Okay, so when you're seeing binomials for now, you should be thinking about difference of 2 squares. All right, let's move on to the next video.